Welcome to Brain Vision.
This problem, let's see here, problem 35. We have a steam power plant, ideal reheat cycle again. In this case, we have, let's see here, we are told we have 15 megapascals up at the high pressure side and 10 kilopascals down at the
XLMUSD moving up to 16.3 at 23:16.
At let's see here, at the let's see, we got what are we at, 10 kilopascals down here. Now we're told that the quality factor at 6 is 90%. Well, we can't exceed a the content of the steam is not to exceed the moisture content is not to exceed 10%. So that means that we have to have at least a 90% quality factor here. The temperature here is 500 degrees Celsius for both cases. We have the mass flow rate is 12 kilograms per second. And so now again, saturated vapor or saturated liquid here at 10 kilopascals. We have an enthalpy of 191 kilojoules per kilogram Kelvin and a specific volume of 0.00101. We can then get the work that the pump did in increasing the pressure from 10 kilopascals to 15 megapascals. And it did a lot of work, and that is, this is a lot of work per kilogram of fluid, and that's 15.14 kilojoules per kilogram of fluid that's flowing through the pump. Then we can add this and this to get the enthalpy at 2, so we pump up the enthalpy and the pressure. At 3, we have pressure and temperature, so we can get enthalpy and entropy. And the entropy at 4 is the same as entropy at 3. At 6, we have, let's see here, no, at 5, we have pressure, did I write that down? No. We have 5, what do we have at 5? We have the temperature and the we have, well, we know we can get 6 we go first, because 6 we have the quality factor, and we have the pressure, so we can get the enthalpy and the entropy, and then we know the entropy at 5 is the same as the entropy at 6, and so we know the entropy and the temperature at 5, so we get the pressure. So the pressure at 5 winds up being 2.15 megapascals. Let's see here. And so the enthalpy at 5, we can get that. And we can get the enthalpy at 4 because we now know this is also the pressure at 4. So that's a constant pressure line. And we know the pressure at 4, and we also know, what else do we know? The entropy at 4 from here. So we can get the enthalpy at 4. And from that, we can get the heat, the rate of heat supply is the mass flow rate here times H3 minus H2 plus H5 minus H4. And that winds up being about let's see, 45 megawatts. And so we can get the rate of heat transfer out in the condenser, and that is the mass flow rate times enthalpy here minus enthalpy here, and that winds up being about 26 megawatts. And from those two things, we can get the efficiency to be about 42.6%.